Right now, at this exact moment, there is a star dying. Not slowly, not quietly. It is convulsing, heaving, shedding enormous plumes of its own atmosphere into the void. Its surface churns like a boiling ocean the size of our entire inner solar system. And it has been doing this for years, flickering like a flame that someone keeps trying to blow out. We can see it with our naked eyes tonight. It is one of the 10 brightest stars in the sky. And for the past several years, the world's most powerful telescopes have been pointed directly at it, watching, measuring, waiting. Because sometime in the next 100,000 years, or possibly in the next few decades, Betelgeuse will die in the most violent explosion the universe knows how to make. A supernova so bright it will be visible in broad daylight. And recently, while scientists were staring at it, they found something hiding in its shadow. Something we missed for over a century. Stay with me, because this story just got a lot more interesting. Before we talk about what they found, I need you to actually understand what Betelgeuse is, because the numbers here don't just impress, they disorient. Our sun is approximately 1.4 million kilometers across. If you replaced our sun with Betelgeuse, its surface would extend beyond the orbit of Jupiter, Mars, the asteroid belt, Jupiter itself, all of it, swallowed, gone, sitting inside this single star. And yet, despite being nearly 900 times wider than our sun, Betelgeuse is only about 10 times more massive, which means its density is extraordinarily low. It's essentially a massive, glowing, semi-stable cloud that barely holds itself together under its own gravity. Its outer layers move constantly, rising and falling in enormous convective plumes, each one larger than our entire sun, as heat from the nuclear furnace at its core tries to escape. It sits 650 light-years away from us in the constellation Orion, forming the hunter's left shoulder, and it is the closest red supergiant to Earth. That matters. That matters a lot. Here is something most people don't fully sit with. The light reaching your eyes when you look at Betelgeuse tonight, that light left the star in the 1370s. Chaucer was finishing the Canterbury Tales. The Black Death was still fresh in Europe. And Betelgeuse, in that moment, fired off the photons that are just now landing on your retinas. Which means we have no idea what Betelgeuse looks like right now. Right now, in the actual present, it could already be gone. It could have exploded 300 years ago, and the light from that explosion is still racing toward us at 300,000 kilometers per second, with centuries still left to travel. There is a version of events where Betelgeuse does not exist anymore, and we simply haven't found out yet. That's not a metaphor. That's physics. So, how does something like this end? For most of its life, a massive star like Betelgeuse is in a standoff. On one side, nuclear fusion in its core, where hydrogen atoms are crushed into helium, releasing enormous energy that pushes outward against the star's own gravity. On the other side, gravity, always pulling inward, always trying to collapse the whole thing. For millions of years, these two forces are perfectly matched. The star burns steadily. But stars are not infinite. Eventually, the hydrogen in the core runs out, and then the star begins to burn helium, and then carbon. and then oxygen and neon, each time producing a heavier ash of elements in the core until it reaches iron. Iron is the endpoint. You cannot get energy from fusing iron. It actually costs energy. So when the core of a massive star fills with iron, fusion stops and the standoff ends. Gravity wins instantly. The core collapses in less than a second, from roughly the size of Earth to the size of a city. And the shock wave from that collapse, when it hits the outer layers of the star, triggers an explosion so enormous that for a few weeks, a single star can outshine an entire galaxy of 200 billion suns. That's what's coming for Betelgeuse. In late 2019, something strange happened. Betelgeuse, already one of the most studied stars in history, began dimming. Not subtly. By February of 2020, it had faded to roughly a third of its normal brightness, the dimmest it had been in recorded human history, going back over a century of measurements. The internet erupted. Astronomers scrambled. And for a few weeks, the question on everyone's lips and in the headlines of every science outlet on the planet was, is this it? Is Betelgeuse about to go? The short answer turned out to be no, or at least, not yet. Data from the Hubble Space Telescope pointed to a different explanation. In the months before the dimming, a massive outflow of hot material had ejected from the star's southern hemisphere. As this cloud moved away from the surface, it cooled, and that cooling caused the material to condense into dust, dark, light-blocking dust that drifted across our line of sight, partially eclipsing the star from our perspective. Not a precursor to death, a star sneezing. But here's what that dimming did that no one expected. It made the entire world of astronomy point their instruments at Betelgeuse all at once. Every telescope, every research group, every graduate student with a data pipeline. For months, Betelgeuse was the most watched object in the sky. And that's when they found it. For over 100 years, astronomers had suspected Betelgeuse might not be alone. Stars frequently come in pairs, binary systems where two stars orbit each other, sometimes so close they share material, sometimes so far apart the orbital period stretches for centuries. Our own Alpha Centauri system is a triple star. Most massive stars, in fact, form in the company of at least one sibling. But confirming a companion for Betelgeuse was extraordinarily difficult. The star itself is so large, so turbulent, and so bright that picking out a smaller object in its neighborhood felt like trying to spot a firefly orbiting a bonfire from 1,000 miles away. The dimming cycles of the star added another layer of noise. Betelgeuse brightens and fades across several overlapping cycles. One roughly 400 days, another around 2,100 days. Researchers had long debated what drove these rhythms. Some attributed them to the star's internal pulsations. Others weren't so sure about the longest one. After 2019, two independent research teams, one at Harvard, one at the Flatiron Institute in New York, looked at archived positional and radial velocity data for Betelgeuse going back decades. And they noticed something subtle. The star's position in the sky wasn't just drifting with its own motion. It was wobbling, a tiny, periodic wobble, back and forth, on a 2,170-day cycle. There is only one thing that makes a star wobble like that: gravity from something else. Both teams concluded that Betelgeuse has a companion star, quickly nicknamed. Researchers at the Gemini North Observatory in Hawaii then attempted to actually image the companion using a high-resolution speckle imager that compensates for atmospheric distortion by taking thousands of rapid exposures and combining them. They timed observations for when seaward would be at its maximum predicted distance from Betelgeuse, trying to catch it in the brief moments when it might peek out from behind the glare. The results were inconclusive, but not dismissive. The hunt is ongoing. Now let's talk about Earth. When Betelgeuse explodes, and it will explode, what do we actually experience? The blast wave itself, the expanding shell of ejected stellar material, will take thousands of years to reach us. And by the time it does, its intensity will have spread across such a vast volume of space that it will be weaker than the pressure of the solar wind our own sun already constantly pushes against us. Our heliosphere absorbs it without breaking a sweat. The radiation is more interesting. At 650 light years, Betelgeuse falls well outside what scientists call the kill zone for supernovae. Roughly 25 light years, inside of which the radiation and high-energy particles from an explosion could strip our ozone layer, devastate marine food chains, and trigger mass extinction. We are 26 times beyond that threshold. What we will experience instead is something almost unimaginably beautiful and strange. Betelgeuse will become visible during the day for weeks, possibly months. It will glow in our sky like a second moon, bright enough to cast shadows at night, impossible to miss even at noon. Billions of people will see it. Every culture, every city, every child who happens to look up. It will be the most widely witnessed astronomical event in human history. The last time a supernova was visible to the naked eye was 1987, and that one, SN 1987A, was in a satellite galaxy 160,000 light years away. Before that, the supernova of 54 AD, which left behind what we now call the Crab Nebula, was so bright that Chinese and Arab astronomers recorded it remaining visible in daylight for 23 days. Betelgeuse is 100 times closer than that. Here's the thing about Betelgeuse that I keep coming back to. We are watching a star die in real time. Every instrument we have, ground-based observatories, space telescopes, radio arrays, is feeding us data on a process that takes millions of years. And we happen to be sitting here at just the right moment to watch the final act. And that final act has been more surprising than anyone predicted. A companion star hiding in the glare for a century. A great dimming that turned out to be the star's own expelled dust drifting across our view. Pulsation cycles that still aren't fully understood. A star behaving erratically, unpredictably, in ways that keep upending our models. When it finally goes, the data from that explosion will answer questions we've been asking for decades. What exactly happens in the core during collapse? How do shock waves propagate through a stellar envelope? Does the companion star survive? What remnant is left behind? A neutron star or a black hole? We don't know. We genuinely don't know. But we will, because when the light arrives, every telescope on Earth and in orbit will be watching. And so, hopefully, will you. If you want to see a supernova in your lifetime, this is your star. Keep watching it. Keep caring about it. If you're new, subscribe. See you in the next one.